Okay, good morning. So this is a question that we've all been taking a look at. This more or less the rehearsals, right? So we have two arrays we're supposed to create. Imagine there are about three arrays, and then the values of the arrays x and y are supposed to be gotten from the user, and even the length of the array as well. The arrays have the same size. The values of x and y to be gotten from the user. I think I've written down twice. Okay. The values of z are supposed to be computed by multiplying the corresponding values of x and y arrays. So z as position 0 will be gotten by getting multiplying x at 0 and y at 0. Basically, you're supposed to calculate v. So v is more or less, this is how we get the values in y. So x at I, y at I. Eventually we get the values. And this thing is more or less like saying z. Okay. So as we multiply these two values, we can find the sum, keep it in a variable. And then we find the standard deviation of the this one of the x. Okay. Find the standard deviation of the y. And then we will find the continuous subtraction of every member of y. We'll take it out from the x bar, and x bar is going to be the mean of items in the x array, right? We can get a function to do that for us, and eventually we find the standard deviation of z, which was computed using this approach. So on the next slide, we'll see how to do that. I'll first begin by declaring all my functions before I start the main program. So this is the formula for standard deviation. If you want to refer, I think one of the examples that we've been solving on standard deviation, we always forget the square. This time, let's not forget it. So we start by declaring a function. Now, usually, it will be appropriate if you write declare, then you write the function name. Okay, so the keyword declare must come in front. All right. We declare, and because we are going to find the sum, we bring sum equals 0. And then we get our for loop, which is going to run from 0 to the size of the array. This means we have an array called list that was going to be passed to the main function, and we'll get the size of the array. Because we are writing pseudocode, we cannot determine it naturally. So what we'll use is we'll have to pass in another value which talks about the size of the array. So we loop from 0 to the size minus 1. And anytime we loop, we need to add 1 to sum. Okay, I think that this one, sum equals this one, there should be another value. Hold on. 1, 2, 3. So we add the value of sum like this. I think that's not the only place I made that omission. There should be there should be some, that very value of sum should be added again, right? Sorry for the omission. Sorry about the omission. So let's go there again. Plus subtract. All right. So now we're here to add sum to the value of the list item that's coming. When you are done, end your for loop, then you return the sum divided by the array. This one we all understand. We end our function. So I'm only declaring the functions over here. I start a new function called stdev, which takes in a list and the size of the array. And then we calculate x bar. X bar could be any value at all, but that's the mean of the list that was passed in. We pass in the list into the main function that's already been declared up here. calculate subtract, which starts at 0. And then when it starts at 0, we have subtract being equal to 0. We loop from 0 to the size of the array minus 1. And what we do over here is we will calculate this. So for every value of x bar that we have, we will take, okay, I think I made it the other way around. It's supposed to be the list items position minus x bar. So I interchange it over here. Check it, okay? All right. And then there is an internal function called POW. It's a math function, which will help you find the square. If you don't write POW and then use that caret sign, which is like this, look at the hand, it's like this, being turned upside down. No big deal, but use this function, okay? Well, not all programming languages use that particular caret sign as exponent, so always use a POW in terms writing your algorithm. So eventually, we add the value of the subtract that we've gotten already. So subtract is more or less the difference, okay? We are adding this particular difference continuously to the previous summation. You understand this? And you return subtract all over size of the array. So this is how we sort of attempt to try this particular stuff, okay? When you are passing arrays to a function and those kind of stuff, you return subtract all over side. We end our function. So basically what I've done right now, I've declared two functions that I'm going to use in my main program. So this is where I start my program. Input number of spaces, okay, which is the size of the arrays, because they said they have the same size. And when you are done, you declare the arrays. So I now declare the arrays and pass in the sizes. I got a size from the user, so I pass in the sizes. And then when I'm done, I get sum z equals 0. This is what I mean by sum z. When you move to the previous slide, there's a size. Over here, there's more or less the z. Okay, so because we get z by multiplying the corresponding values of x and y. That's why I called this whole thing sum z. It's like adding the elements in z. That's why I call it sum z. You can call it any value you want. So sum z equals 0. And we loop from h equals 0 till we get to the point where we take the values to number of spaces minus 1. And so we are going to take the values of x, we can take the values of y, because we don't have them anywhere. So that's why we take them. When we take them, what we do next is z at h is going to be equal to the corresponding values of x and y at that very h, multiplying themselves. Eventually, you assign it to z at h. And then sum z will be equal to that value plus h. And I said that aside the fact that you are adding these two, you should add the value of sum z to it. It should have come by now. Let me see. Wait. I think I made a mistake. Let me correct that one too. Okay. What did I do? Hold on. 1, 2, 3. So this more or less finding. Good. So this is how it's supposed to be. So I've corrected it. Now we find a z h and then we add it to sum. That's sum z. Don't be in a haste to try and understand. That's what I'm basically trying to, what do you call it? Don't be in a haste. Okay, so we have this. Now we are able to add the summation of all the sums to it. We end up for sum diff. Sum diff is the difference after taking, so that's what I mean by sum diff. 1, 2, 3, where is it? So the difference between the x bar and the I. Okay, that's basically what I mean by the sum diff. Let me even correct that part I was talking about in the code 123 123. Here it is the value minus x bar. I think that's what the standard deviation was saying, right? So this value minus x bar. Good. So let's come back here. All right. So look at the direction within which I write my code. You declare your function before you now write your code. Don't do it the other way around. All right, so that it will be clear. So in this case, sum diff equals 0. We are going to find the continuous difference between the mean of x and the corresponding values of y. Basically, p equals 0 running till we get to n minus 1, or the number of spaces minus 1. You basically get what I mean. And so we do that. This is going to find the mean of x all the time. You can put it in a variable if you want, no big deal. Minus y. So this whole thing can be in a variable called x bar. You can do that. You can do that up here or wherever. And then you take the values of y from it anytime the loop runs. So sum diff y is going to be like this. And then you end your for loop. And this is basically the expression. So the expression on the other side, v equals whatever, whatever. We find sum of z. So sum of z is basically this value. So this value, we know this is how we get our z. So sum of z is basically this value. And we find the standard deviation of x and y, and we make sure that this particular thing carries this as a power. That's basically it. Then the whole thing at the top will be divided by this thing down here. That's what I've done here. I can see your screen is small, so I migrated the stuff over here to the next slide, and you can have them like this. Yes, there are some modifications I made on the other side, so let me correct them here. So these are the modifications I made, plus some diff, like this. And then we have some z. I think I did that. That's basically it. So, but if you have any questions, you can still ask. And that's basically it. Okay, so aside the function declaration that I had on the other side, this is the code for the whole program, because you've already declared your functions as mean and stdev. Okay, we have our stdev and then the mean. Some of the functions are called in other functions. So this is the code. This is basically the whole code. And then for the function part, we don't have it on a separate slide. So let me get a slide, an empty slide, and show it. So this is the code. This one is for the function. So my mean, my whatever, whatever. So it's over here. We already given the explanation. If there's any problem, try and correct it. This more or less to help you know how you write things of such nature. Okay. Like that. So I will end here. No long talk.